This section is about absolute value equations and inequalities and solving them. So before we jump into actually doing the algebra, let's remember that the absolute value of a number A is written with solid lines next to it, and it's telling us the undirected distance from 0. So how far is that thing on a number line from 0? And we don't say -3 or 3. Sorry, we don't say -3, -4, -5. We say it is 3 units, 4 units, or 5 units. It is only a positive result. Sometimes we don't just want one number that is a certain distance, we want the span of numbers. So if we want all the numbers that live between -3 and 3, that would be all the numbers A, whose absolute value is less than 3, then that would be from -3 to 3, because everything in there has an absolute value that is smaller than 3. If we wanted to say the absolute value of A is greater than 3, that means we could be on a number line, -3, 3, -4 over here, 4 over here, everything in here would be my answer. So the answer to this one would be from -infinity to -3, and then union 3 to infinity. So when we solve inequalities, we can have a single answer, but we also can have a span of values. Quick little reminder. If I have an equal sign, it results in a closed dot. Less than or greater than, parentheses, parentheses. If it's sandwiched in between, the shading should be in between. And if it's an or statement, I should have this or this. So let's jump into doing some math. So let's do this first problem. So it says the absolute value of 5 minus 3x equals 12. So there are two cases to consider. There are two numbers that have an absolute value of 12. So case 1, my 5 minus 3x could equal the 12. The other case is 5 minus 3x could equal -12. And that's because the absolute value of 12, oops, I wrote that again, sorry. That's because the absolute value of 12 equals the absolute value of -12, and both of those equal 12. So we're just going to solve these like we normally would. So I'm going to minus my 5 over to both sides. -3x equals 7. Similar over here, minus 5 from both sides. -3x in this case equals -17. Divide by -3. X equals -7/3. X equals 17/3. And then we need to check. So I'm going to do absolute value of 5 minus 3 times -7/3 equals 12. And we're checking it, so question mark. The 3's are going to cancel off, so I'm going to get 5 minus -7. That's the absolute value of 12, which does equal 12, so that one works. Need to check my other one. 5 minus 3 times 17/3 equals 12. The 3's cancel off, so I'm left with 5 minus 17, which equals the absolute value of -12, which does equal 12, so both answers work. So answer, and we should probably write it as a solution set. So bracket -7/3, comma 17/3 is my solution set. I have two things that will make this work. Okay, in the next one, two different scenarios. So in this one, 4x minus 3 could equal x plus 6. And if those two things are equal, then this will work out. The other thing that could happen is that 4x minus 3 could equal the negative version of x plus 6. because if you take the absolute value of a negative, it still becomes a positive. So I'm going to solve this one over here first. So I'm going to subtract the x over. I get 3x minus 3 equals 6. Add the 3 over. 3x equals 9. So x equals 3. Do the same thing in my other one. But I'm going to have to distribute first. So 4x minus 3 equals negative x minus 6. I'm going to add the x over and get 5x minus 3 equals negative 6. I'm going to add the 3 over. So 5x equals negative 3. Divide by 5. X equals negative 3/5. Before we write either one of them as a solution set, we should check them. So my first one, I'm going to write absolute value of 4 times 3 minus 3 equals question mark 3 plus 6. I'm plugging in the 3 first. So this gets me the absolute value of 12 minus 3 equals the absolute value of 9. Absolute value of 9 equals the absolute value of 9. That one works out. And the other one, 4 times negative 3 over 5 minus 3, absolute value equals question mark negative 3 over 5 plus 6. You can use a calculator and do 4 times negative 3 over 5 and subtract 3. You should get negative 27 over 5 equals, you can use a calculator for this too if you need to, 27 over 5. And the absolute value is going to make those two things equal, so it works. So my solution set is, we always write small to big, so negative 3 over 5, comma 3. There's my solution set. Okay, so let's go to our first problem. So since I need 2x plus 1 to be less than 7, when you have that less than, you can solve this as what I was taught to call a Christmas tree. So here's the star at the top of my tree, and I have 2 branches. And in the middle is 2x plus 1. And if I want the absolute value of 2x plus 1 to be less than 7, that means I also need to be greater than negative 7. So this gets sandwiched in between. And then we go down and we're going to solve. So I'm going to minus the 1. Remember, we learned this in our last section. If we have 2 inequality signs, we have to do it in all the places. So now I get negative 8 is less than 2x is less than 6. Divide by 2, and if you do it in one place, you have to do it in both of the other places. So you get negative 4 is less than x is less than 3. So I can write this as an interval from negative 4 to 3, and everything in that interval is my answer. The next problem is very similar, but it's not a Christmas tree problem, and it's because the absolute value is greater than. So in this case, we have to consider 2 versions. So here's my first version. 2x plus 1 could be greater than 7. If you multiply everything there by a negative, so what I'm doing is 2x plus 1 greater than 7. And if I multiply everything by this negative 1, then 2x plus 1 will end up being less than negative 7. So then I'm going to get, on the other side, 2x plus 1 is less than negative 7. And so this is an or statement. I am not sandwiched in between them. I live on the outside of both of them. So we're going to solve these separately, though. So minus the 1 over 2x is greater than 6, divide by 2, x is greater than 3, or minus 1, minus 1, 2x is less than negative 8, divide by 2, x is less than negative 4. So if you think about a number line for a second, this says I'm at negative 4, and I'm less than that, I'm going this way. Or I'm 3 and I'm getting bigger. So my shading is going away from each other, and since my shading goes away from each other, it's an or statement. And then using this number line, we can write negative infinity to negative 4 union 3 to infinity. Last handful of problems. Okay, in this example, we can't do anything until we isolate that absolute value. So I'm going to add the 1 over and add the 1 over. So I have 2 minus 7x. Sorry, that was supposed to be an absolute value. 2 minus 7x is greater than 5. Because the absolute value is greater than, it's an or statement. So two versions. 2 minus 7x is greater than 5, or 2 minus 7x is less than negative 5. Solve the two equations independently of each other. So minus 2, minus 2, negative 7x is greater than 3, divide by a negative 7, divide by a negative 7, x, because you divide by a negative, flip the inequality, x is less than negative 3 over 7. Let's go solve the other one. So minus 2, negative 7x is less than negative 7, divide by a negative 7. Again, remember to flip your inequality sign. X is greater than 1. So here are my two answers, and then I have to write it as an interval. So if x is less than negative 3 over 7, less than that negative is negative infinity, comma, negative 3 over 7, union, and then I'm going to jump to 1. This says x is bigger than 1, so I go from 1 to infinity. So let's do these bottom few examples of special cases. And these special cases just need you to take a second and step back and think a little bit logically for a second. So in letter A, it says this absolute value thing, abs value, is greater than or equal to a negative 4. Well, absolute value is always positive. So a positive is greater than or equal to negative 4. And for this, the answer is all real numbers, which we write as negative infinity to infinity, because a positive is always bigger or equal to the negative 4. A positive is always bigger than a negative. So the answer for letter A, all real numbers. Letter B, we're going to look at logically again for a second. Letter B says my absolute value is going to be less than a negative 3. Well, absolute value is always a positive number, so positive less than negative 3. This never happens. A positive is never less than a negative 3. So there are no solutions, which means my answer is the empty set. The last one is a very special case because it equals 0. 0 is not positive or negative, so I can't change it. Like if that 0 were a 7, my absolute value could inside equal positive or negative 7, but the only thing that equals 0 is 0 itself. So the only way to make this happen is if my 5x plus 15 actually equals 0. So minus 15 from both sides. 5x equals negative 15. Divide by 5 and divide by 5, x equals 3. In this case, I have a lone solution of 3. Not a range of values, just a 3. Oh, sorry, not even a 3. Positive divided by negative is a -3. -3. So just a -3 is my solution.